So, this is a talk about Elm. Can everyone hear me clearly? Yeah? Okay, awesome. And Elm sells itself as a delightful language for reliable web apps. But I'm going to focus on the first bit, the delightful language. Like, what does it mean? Why do I need a delightful language? Why can't I just, write JavaScript and be done with it? Because we all know JavaScript, right? So first, like, tiny show of hands. Does anyone know about Elm? All right. Has anyone ever tried Elm? That's basically the same thing. That's kind of nice. Anyway, so Elm. First of all, who am I? I'm Ilias. Hi. I work here at Kunstbaan, and I'm very active in the Elm community. I'm on Slack basically all the time. I answer questions, I write code, and I have a GitHub thing, and I also have a blog thing where I occasionally post something about Elm, but not enough, I'm afraid. So, this is the front page of the Elm Lang website, and it sells itself as a delightful language for reliable web apps, which means that it generates JavaScript with great performance and no runtime exceptions. So this no runtime exceptions thing is kind of important about Elm, because, well, what does it mean? Well, you don't get this. You don't get foo is not a function, undefined is not a function, cannot find property foo on undefined, null is not an object. All these things, it doesn't happen in Elm. Like, you see this all the time in JavaScript. And even though it generates JavaScript, you just don't see those errors because they don't happen. But what I want to focus on is that it's delightful, right? So, first of all, what is Elm? Elm is a functional programming language. I think most of us have heard about this functional programming thing, and if you're working with React, you know, like, okay, I have to write functional components and stateless components and write using arrow functions and not using prototypes and objects. And we all know a little bit about what it is, but at the same time, most of us are like a little afraid of it because, it has all these weird words and concepts like monads and monodes and applicative functors and co-free monads. And basically, it's like functional programming. Elm is functional programming. Do I need to know about those things? Well, basically, in Elm, the answer is no, because you don't need those concepts, right? To give a little sense of how I say this, let's say you want to add two numbers, right? That's a sum operation. That's just adding two numbers. And if you really want to know, then there's this whole thing of set theory, group theory, that you can apply to this operation of adding numbers. But you don't need to know that to add numbers. Same way, you don't need to know about monads, monoids, all these things to write functional code. So that's not necessary in Elm. Instead, we have basically two important concepts, and they're quite simple, really. So on the one hand, we have pure functions. What does this mean? It's a pure function means that you take input and you give back some output. That's basically what a function does, right? But the important thing about pure functions is that they don't have side effects. So let's say you have a function that adds two numbers in JavaScript. You can perfectly implement that while also setting some other random variable. And it sounds like this doesn't really happen a lot, but I'll show you some examples that it does happen. The other thing is static typing, and that's also very important because, well, basically you say, I have a string, I have a number. What happens if I add these two together? Well, in Elm you can't because there are two different types. Everything is statically typed, and you can't make mistakes like calling a function on a string, because then you get the undefined is not a function thing. So in Elm, that's the two main reasons that you don't actually see these things. I'm going to do something risky, and I'm going to try some very simple example of how that happens in JavaScript. So let's zoom this in a bit. Right? Is it legible? Yeah, it is. Okay, so let's go into a JavaScript REPL and let's start off with okay, so who knows what happens when you try to add two things in JavaScript that you can't actually add together? Like, say I have an object and I have an array. What happens? Well, JavaScript is a little weird and it says it's 0. Okay, fair enough. Now, there's one thing that's very important about adding two things. In basic mathematics, it's a commutative thing, right? So if you swap the arguments, you get the exact same thing. If I add 1 and 2, and I add 2 and 1, it's both 3. JavaScript does not agree, and it makes it a string of object in an array. It doesn't really make sense. Same thing goes for if you say, like, this is just an empty array of 16 elements, right? Now, if I join them with a string what, and I add 1 to all those, no, let's start with this. So that's just, that makes sense, right? You have 16 empty elements, you join them together, you get 16 times the string that's in between them. If I add 1 to those, so adding 1 to a string, what does it do? Well, JavaScript goes like, okay, sure, I'll just make string out of 1, and I'll append it to your string, and there you go, what one, and so on. The curious thing is that if you swap the operator and say, I want to subtract 1, you get something completely different. And I can make this a little bit more like predictive in what it might be. Does anyone have a clue of it, what this will actually go like? Yeah, so that goes like this. And this is what you get when you don't have static typing. You can do things that don't make sense, and the language can't really protect you from it, and it'll just go like, you give me nonsense, I'll give you nonsense back. The sad thing is that you don't often intend to give it nonsense. It just happens to be that, like you define something there, and then 20 files later you do something with it, and it has changed, and it's not what you expect it to be, and it breaks apart. So let's have a little look at side effects, because they're also very cool. Let's say we start with a regex. Is any character globally? Right. So this is just a regular expression, right? That makes sense. Now, if we also take a string, let's say hi, and we say it's hello world. Now, if I execute this regex, which just matches any character, because that's what a dot means, it says anything, and we also gave it a global modifier, so it's like all over the place or something like that. And we say execute it on the string and take the first match, right? So logically, when I do this, you just get H. That makes sense. What you would expect is that if you do this again, you get the same result, because it's a function. And if we think about pure functions, it will give us the same thing every single time. JavaScript doesn't really care about pure functions, so you get something different. You get the next letter, and next letter, and next letter, and next letter, until you actually run out of letters, and then it just kind of goes like kaboom, because you just try to read a property of null, and you can't do that. So that's also a little sad. One last thing I want to show you is that if I take the same regex and I give it a string, I want to see, does this match this string? I'll get true, of course, because it's just a character, and that's completely fine. And if I do it again, it goes false. And I do it again, it goes true, false, true, false. This is kind of like an example of why we kind of like to have pure functions in a language, so that we can predict what the result will be if we actually do something with them. Now, where's play? There. We've already seen that. Now, what does a basic Elm program look like? So the first thing you have in any program is some kind of state, right? If you have any experience with React, you sometimes use Redux or Flux to get this unidirectional data flow, because it's nice that you have a single source of truth. That's my application state, and everything is defined in there, and the rest just flows from that. In Elm, you have to have this. This is part of the language. If your program doesn't have a model, you don't have a program. Second thing that it has is a way to take like some incoming message, like I say, I click this button, so I send a message, button clicked. You take your model that's currently valid, and you create a new model. This is basically what a reducer in Redux does too, right? You take two things, you reduce it into a single thing, and you take another thing, and you reduce that into a new thing, and so on and so on. And that's how your application kind of flows. And basically what we're saying is like we declare how we want our application to look like after something happened. And it's a very simple mental model of how to write applications. Finally, you have like your view, because you want to show something to your user. Otherwise, you're not really writing a web app. So you have a function to take your model, turn it into a DOM model, and show that to the user. There is one last thing. Basically, now you have 3 pieces. You want to handle the runtime, a single piece, so you just bundle it up into main. Let's actually look at how that looks like, because why not? I'm going to try and zoom this in a little bit without, while still having it legible. All right, so this is a simple counter. For what it's worth, this is Ali. It's the Elm Live editor, and it's a really cool project that Luke Westby made, just because he liked doing Elm, and he figured, like, why not make something really complex in Elm, like a compiler and a live editor in Elm. So what does this do? We have 2 buttons. We have a number. If you press plus, it increments. If you press minus, it decrements. Kind of makes sense, right? How does this look in Elm? Well, first of all, we have a model, and that's just initial model. I named it initial model rather than model because I just want to show, like, this is what I handle runtime. This is my initial state, right? Next part is this update thing where you just say, okay, I have a message type and I want it to be 2 possible things. It's either increment or it's either decrement, and there's nothing else possible. You can't suddenly have a web request coming in. It's just, that's all there is. Just one of 2 things. And this is called a union type, actually. And then we have an implementation of that, and that's kind of interesting because we go like, okay, so my update takes a message and a model, and then I just look at, like, what is my message? Is it increment? And I just return new state, which is I calculated by saying current model plus 1, or it's a decrement. I just, did the other thing. I take 1 away. Kind of makes sense. Then this last thing. Okay, so first of all, this kind of indentation and this kind of comma first before anything else, and it looks a little weird if you're not used to Elm or used to this code style, but it really grows on you. Anyway, the important thing is, though, that in Elm you don't actually have to know that you have to format it that way, because in Elm you have this tool, Elm Format, and basically everyone uses it, with, like, except maybe 2 or 3 people who just don't feel like it. And it formats your code in one simple defined style guide. You can't actually configure it at all. Like, if you prefer to use tabs versus spaces or 2 spaces, 4 spaces. No, there's just one simple tool that is not configurable, and that does your formatting for you. And this sounds weird at first if you're not used to it, because we're used to ESLint, where we can set like 17,000 parameters, and we can have 17,000 options per parameter. So there's like incredibly much possible configurations for this. And in Elm, you just have the one, and this is a nice thing because it means that everyone uses the same code style. You don't have discussions like, but I prefer spaces. No, there's a single code style, and you use it or you don't use it, and it's as simple as that. What does this do? Well, we say it's a div, we give it a button, a div, and a button, and in this middle div we say some text, right? If you've ever worked with React, this will look vaguely similar to JSX, but like vaguely. But if you take JSX away and replace it by how it actually looks like when you render JSX to pure JavaScript, it looks surprisingly familiar. And then finally, we take these 3 little things and we hand them to the runtime and say, okay, this is our program, right? Now, what Elm is also very famous for is its error messages. So let's do a little thing and let's try to add a reset button, right? So I just say, okay, I have another possible message, and I can either increment, decrement, or reset. Now, if I try to compile this, Elm will not like me and say that my case statement there does not have covered all bases. There is another option there, and I didn't take it into account, so I don't get this undefined error. I don't get to choose what to do with it. There's no default action. It just, I have to implement it, or Elm will not compile. And I can just say reset means I give 0 back, right? So my new state at that point is 0. That's how resetting works. And then I just add a new button that says, okay, on click, I want to reset. And I'll give it some nice text, reset, okay, fair enough. If I now hit compile, we get a beautiful reset button. So I can increment numbers, I can click reset to go back to 0, I can decrement numbers, reset back to 0. So this simple model of, you have a case statement, it needs to be exhaustive, it needs to be complete. This is a real lifesaver in Elm, and it's incredibly nice to know that when you give it something, you'll get back something you expect. Another thing that I just quickly want to show is what I did is quite sneaky. I just have I want to show some text and it's my model, but I sneakily put 2 string there because my model is a number, right? And I can't just print that, I have to convert it to a string first. If I remove this, Elm will actually tell me no, you can't do that because it's not what I expected to, in that statement. So I'm going to quickly annotate my types here into HTML message. This is just like a little helper for Elm because it doesn't really know how to it tries to figure out your types, but if you don't tell it what your types are, it will only go wrong at the last possible moment because it doesn't really know what model is if I don't tell it what model is, right? So at this point it just goes, okay, but text needs to be a string and it's an int, so you can't do that. And this is another way in which Elm protects you from making silly mistakes, like adding a number to a string or adding a string to a number or doing these things that JavaScript just goes yeah, fair enough, I can deal with that, and then just does something you don't really want it to do. So this is the basic mental model of an Elm program, right? So we have a runtime that's just it's in JavaScript. We don't have to look at it. We don't have to think about it. We just send it our functions. We hand it some model, and first thing it does before it even goes to your update is just render that model, right? Very simple. And then it goes to your update whenever some message happens. And you don't have to think about what's going on behind the runtime. It sits there. It does what it has to do. It is written in JavaScript, and yet it is actually quite safe because it's very simple JavaScript. If you want to do a real program, though, you'll need some more stuff, right? So you have to initialize your program and say okay, so I want a program that has actually somewhat useful state, not just a string or an int. You have a model, and you want to give it some things to do. Say I want to start my program by also doing an HTTP request and fetching some remote resource and getting that back. You can do all those things. Then there's another sneaky one here, and it's subscriptions. And this is a second way that you can tell your Elm program that there is something happening in the outside world. Subscription, good example is, for example, say you're listening to a WebSocket. When you're listening to a WebSocket, you don't decide when a message comes in. It happens, right? Can't really say, and now I want a message to appear. No, you say, subscribe me to this WebSocket, and whenever something comes in, notify me. And that's what a subscription really is. Or if you want to know the current time, or if you have a time ticker for a clock, you just subscribe to the current time, and whenever something happens, it shows it to you. And this is also based on your model. So you tell it, okay, this is my current model, and if my current model says that I'm actually interested in this WebSocket, it will tell you about it. If you're not interested, forget about it. You won't get any notifications at all. And that's another way in which it's quite simple to just separate, things that happen in the world. You have your HTML where you have comments. You have your update that can possibly generate some comments. You have your init that generates comments, and you have subscriptions, right? Another interesting little tidbit about the view is that it's triggered asynchronously, so you don't have to really worry about it. It's just like your update gave new state. Okay, Elm just hooks in to request an animation frame, and whenever the browser does its next rendering loop, it renders you a view. And this is kind of expected these days because it's also how React works, but it's something nice that you just don't really expect from languages. Finally, there's update, and there's one tiny little thing. It now returns 2 things rather than 1. Just doesn't just give you new state. It can also give you some more comments to execute. Say you click a button and you want a web request to happen. You want to fetch a cat GIF, for example. Then that's the place you do it. So you react to your message that says, this button was clicked, by giving some new state, which possibly didn't change at all, and a comment to tell the runtime okay, go fetch me that cat GIF. It's fairly simple. And this is all these things that are actually done, they happen in the runtime, and you don't have to worry about it. if you're writing JavaScript, you have to worry like, do I use fetch API? Do I use XML HTTP request? Do I use XML HTTP request 1 or 2? Do I want to use it as a promise? Do I want to use it as a callback? You don't really worry about it. Do I have to react to unready state change myself? Do I do it some other way? Do I use a library? Which library do I use? In Elm, you have one library. It's called Elm HTTP. And it does everything that's related to HTTP requests, and that's all there is to it. What I'm getting at here is basically that Elm has a lot of constraints, and it has a lot of things that you don't have to think about, and you don't have to decide, because Elm already made the decision for you. And this is a little weird if you're used to, say, React, where you can do everything. And then you get Elm, and it's like, yeah, no, don't choose. I made a decision. Do you want to use Redux, Redux Saga, Reflux? Is that a thing? No, Flux just it is, I guess. You don't have to choose. This is the Elm architecture, and it works the way it works. And if you're not happy with it, that's sad, but all right, go find another language. And this is weird if you're not used to it, but if you kind of get in the flow, it's really, really easy because you don't have to make choices. Static typing is a big constraint because you have to know about your types, and you can't do things that might not make sense. If you want to add two numbers, and one is a floating point number, and one is just an integer number, you can't just add those. You have to convert either one to a float, or you have to convert the other to an integer. And this is a thing that in JavaScript doesn't even make sense because there's only one number type, and it's number. So that's a big constraint. I do have to mention, though, that like JavaScript people actually know that this constraint is useful. If they didn't know it, then why would they implement flow and TypeScript and all these static typing variable things that just kind of do the same thing as Elm does for you, except Elm has much more knowledge about it and knows that types can't just change. And it has this type built in, so you don't have to choose another library to do it for you. There's one single architecture. You don't get to choose, do I use Redux? How do I use Redux? Do I use action creators in separate files? Do I use action creators at all? Do I make them whenever I need an action? There's one architecture, and it's very simple. You have an update, a view, a model, and basically everything else just follows from that. There's very often one way of doing things, and this is a little unexpected, but if you have a type signature and you want to implement it, in Elm you very much notice that there's often just one way to do it. In JavaScript, you don't really get this, because how do you loop over all the elements in an array? You can write an iterator, you can use yield, you can use the mop function, you can use the reduce function and push all the elements to a new array and return that. There's just so many ways to do that. And in Elm, you just go, okay, list.map, done. There's one way to do so many things, and it's peaceful not to have to choose and not to decide and not to think about things that don't really matter. There's one way for formatting things. I know that a lot of people might be a little scared of this because, well, you have your own preferences and you want your code formatted the way you want it to be formatted, and not just the way some guy on the internet says, like, this is okay. But it really works out rather nice, for me at least. So this is another constraint. It's something that you can't really choose. It has managed side effects. Like, you can't just say, okay, so in this part of code, I just want to make an HTTP request and then use that result and go on. No, you have to hand a runtime a command that says, do an HTTP request, because it's a side effect that goes to the outside world, and then come back, and then you have your result, and you have to choose what to do with it. And this is a little bit of a constraint, but you actually get used to it. Notice that side effects is a very sneaky thing. Like, what's the current time? This is not a pure function, because if you give it, like, you can't give it any input, right? You just want to know the current time. So it's a function that just tells you the current time, but each time you call it, it gives another result. So it's not a pure function. So that's a little bit of a problem. That means that in Elm, if you want to know the current time, you have to create a comment, give it to the runtime, and it will come back to you and say, okay, I have a message for you. The time is now 12 past whatever. And this is also a very big constraint, because you're used to just saying, oh, I need a random number. Okay, math.random times 12. Okay, now I have a number between 0 and 12. In Elm, you can't do that. You have to go past runtime and make this whole loop again. There is no implicit state. And you might think like, okay, I'm using Redux in my project. There is no implicit state. It's all in the state tree. Okay, but how do you handle your inputs? Are they completely controlled? Do you put all the state from every single input field in your model? Very often you don't, because it's just so much work. But in Elm, it's the only way to do it. You can't know what's in an input field unless you tell the input field to send its value to your model every time it changes. Another big constraint. It has limited syntactic constructs. Like you have a very, very, very small, simple syntax. Like it's completely possible to know all the syntax that exists in Elm after like 2 weeks. It's completely possible. In JavaScript, I don't think there even is a single person who knows every single syntactic construct. Like how do you create, well, everyone knows how to create arrays, but like what's the difference between, like the actual difference between an arrow function and just a named function and an anonymous function? And they're all things that exist in JavaScript and no one really knows what the actual implications of those are, but they exist anyway. In Elm you have very limited constructs, and there's just one way to write a named function, and there is one way to write an anonymous function, and that's it. You don't get too many surprises, like you don't get into a new project where they chose a different subset of the syntax and you see different things being used. And in other languages, you do often, very often see this. Every single company has like their own style guide and their own subset of JavaScript that they like. And they're like, we only use const and let, we never use var. And then you go to another place and they're like, oh no, we still use ES 2015, we only use var, we don't like const let, we have to turn file, we don't like that. In Elm, there's just, you don't really have const, var, and let because you only have immutable variables. What I'm getting at though is that all those constraints, and there are even more constraints, like you can't have circular dependencies, blah, 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 blah. All these constraints mean that you just don't have to choose. You don't have to choose, do I use var, let, const? You just use whatever is available, and there is nothing else. You don't have to choose, do I use React, do I use Angular, do I use Dart, do I use whatever else? There's Elm. Do I use ESLint, do I use Prettier, do I not use anything at all? Well, no, there's Elm format, that's the only choice. Do I use Node-Tap? Do I use Karma? Do I use Mocha? Do I use Jasmine? Whatever you use, no, in Elm there's Elm test, and that's it, there's one option. Everything else, well, no, there's nothing else, there's just one option. All these constraints just mean that you don't have to think about what's not actually important, because whether you use Mocha or Jasmine or whatever, it doesn't change whether your code is worth something. What does matter is, does your code do what it's supposed to do and nothing else? And you have to make all these choices in JavaScript and modern web arc, like, do I use service workers? Do I not use them? There's so many choices and they don't really matter. They don't change what your end product looks like. They don't change what your end product feels like. They don't change what it does. They're just choices that you have to make and that keep you from doing what's really important. That's implementing working code. Elm doesn't really do that. It just goes like, okay, well, this is it. Go for it. And oddly, I think that's kind of like what makes it really delightful to me. You don't have to choose. The choice is made for you, and the choice is made very sensibly, and there's been a lot of thought put into it. So what do we have in Elm as tooling? Well, we have Elm Make, which is a compiler. I showed you that little error message in Ellie before. That's the kind of compiler messages you get in Elm. Like when you compile your Elm code to JavaScript, something goes wrong, it will tell you exactly what went wrong, where, on what line, what it expected, what it didn't expect. And these error messages are actually like they're world class. It's one of the things that people like most about Elm, even people that don't actually use Elm. The people from Xcode are also using now this level of error messages as their inspiration for adding new error messages. And it's happening all over the place. Flow is looking into it, TypeScript is looking into it, because all these tools, they have error messages and they kind of suck. You don't know what to do. Just see an error and you're like, okay, what? We also have Elm package. This is a very important one. So in the JavaScript world, you have NPM, you have Bower, which is kind of deprecated, you have Yarn. And they kind of use all the same packages, and none of these packages is like consistently versioned. Like, say you have a package that does something and it's at version 1.0.0 and you get a new version of it, it's 1.0.1. You can hope that they use semantic versioning and that it didn't actually change anything except some behavior that was a bug, but you can't know it for sure. In Elm, everything is strictly versioned. Like if you want to publish a package, you have to say to Elm package, I want to bump my package version. It will look at your current API, it will look at your previous API. If nothing in your API changed, it's a patch level change. If something was added, nothing removed, it's a minor. It does all these things for you. You don't have to think about it. You don't have to decide how you want to use semantic versioning. It just does it for you. Elm Reactor, which is just like a very interactive way of writing Elm code. So you just refresh the browser and your code is recompiled and it just shows up. It's a nice little tool. Elm REPL, like I used the Node REPL earlier, like a read eval print loop. Well, Elm also has this. And there's also plenty of community tools. So we have Elm Test, Elm Doc Test, which has now been renamed to Elm Verify Comments, Elm Analyze, and Elm Benchmark. Just quickly, Elm Test is to test your actual code. Elm Doc Test is another interesting one. In Elm, every package that you publish, every function that you actually expose to the world, you have to document. It is mandatory. You cannot publish a package without documenting what a function does. You can't. And what you can actually do is, in your documentation comment, you can use some code examples, like how do you use this function? You see it a lot in other packages too, but in Elm you can actually verify those comments like you actually can do in some other languages too, like Python and Elixir. But in Elm this is a very nice tool, and if you're ever going to write Elm and publish package, please use that. Elm Analyze is just like static analysis, tells you like how you could improve your code. Elm Benchmark is for running benchmarks. And then you have a lot of other community projects. Elm Live is for quickly coding Webpack, so you can use Elm with Webpack, which is interesting. And if you use Rails, I don't know if anyone here uses Rails at all, ever? No? No Rails? Great. But you can use it with Elm too, it's built in. React Elm components, well, if you figure like, okay, I'm going to start using Elm, you don't have to do everything in Elm. You can just take one component that's in React and go like, okay, I'm going to rewrite this in Elm, and then use React Elm components to just make a React component out of your Elm. So it's another way, like you don't have to do it all at once. Like if you want to use React, it kind of makes sense to do your whole application in React. If you want to do AngularJS, you do your whole application in Angular. If you want to use Elm, you're free to just do one tiny little single piece of your application and try it out and feel how it goes. And then just because, well, I don't know if anyone cares, but I'm really excited about these things. Sneak peek at next Elm, because well, it's coming soon, but who knows when. It has a faster parser, faster compiler. They're already really fast, but they're going to shave off like 50% more of the time, which is going to be really cool. They're going to focus a lot on making single-page replications. So there's like, currently, if you want to do routing, you have to implement a router and say, okay, this route goes to this page. What's planned is that instead of doing that yourself, you just write your Elm package.json and say, these are my routes, and it figures out like what code goes into what route. It can statically analyze it and say, okay, this is your bundle for that route, this is your bundle for that route. And you only get the bundles for those routes that you actually need, and you don't have to think about it anymore. Also code splitting, which is kind of handled by that already, and tree shaking, so you don't actually get any code that you don't use. That code, well, it's just, you don't use it, throw it away. We know about it because we can analyze the whole program. Some better core implementations of array and random, which sounds a little weird because you consider them like really important types, but array is actually not that important in Elm. Random is really cool though, because it's much faster, more stable, and better tested. And then the removal of the whereas bang operator, which no one ever uses ever, except people that think it's cool. But yeah, it's this weird operator, and it's just basically a bang, and you put it between two things and makes a tuple out of it and makes a comment out of the last part. It doesn't make sense, and it's going to be removed because, well, why not? And actually, I think, yeah, that's it. So thank you all for being here. Thank you for your attention. And I hope you want to try Elm at some point. If you do, you can hit me up. I'm on Slack. Not all the time. During work hours, I usually work. But when I'm at home, I'm often on there. Or if you just want to ask me some questions, feel free. I like talking about Elm, and I like teaching people Elm. So, thank you.